welcome everyone to Introduction to Peering with Chris Grundman and Dave Siegel. Let's get a sense for who's here. If you click the chat button in your window, hello from Amsterdam. Mikkel, you beat me to the punch. Go ahead and let us know if you're on the live stream just by letting us know where you're connecting in from.
Phoenix, Mike, thanks. Philly, Boulder,
Colorado, nice. Columbia, Missouri, Sao Paulo, Brazil.
nice.
Another person from Phoenix, excellent. Omaha, nice. Evansville, Indiana. Another Phoenix.
And another Brazil.
And another Brazil. Two folks from Brazil, awesome. California.
West Coast representing.
San Diego, California. Philadelphia. Sorry I missed you, Craig. Awesome. All right, well, it's 2 after. We're going to dig in here in just a minute. Let's get a sense for where everybody's at. So we've called this Introduction to Peering, and I've noticed more than a few people that don't really need an introduction to peering, but a few of you, maybe you do. So if your current job is peering and interconnection related, just drop a 1 in the chat. Current job is peering and interconnection. Get a couple. And then if you're brand new to peering, if you 0.99 Leo. Yeah, I mean, not exclusively. If peering is part of your current job, you can also leave a 1. If you really do need an introduction, if you're, if you have like a general idea of what it is, but you're here to kind of learn more about it, drop a 2 in chat. 2 or more. Nice, Jonathan. Come on, Harshava, you're not a 2. Harshava's from a peering family. Her and her husband both do peering.
Oh, nice. There's a -1, I guess. You double it up.
All right, let's get into it. So let's start with an introduction. My name's Dave Siegel, CEO of NetMavens, and thank you all for coming to our webinar series where we are educating folks about a variety of topics that NetMavens happen to be experts in. And joining us today is Chris Grundman. He's been a NetMaven now for a couple months officially, but technically much longer than that because Chris and I have been working together on projects for a couple of years now. I think we worked on our first project together back in the beginning of 2023. So welcome, Chris, to the webinar. And for those of you that also aren't aware, haven't checked out his profile yet, Chris has been super active in a bunch of things. Show everybody your shirt, Chris.
It's IX Denver today.
One of the founders of IX Denver, and like still basically running it as well. So that's awesome. Founder of Network Automation Forum and the AutoCon conferences. Founder of Full Control, which has a bunch of automation projects related to peering, including complete and utter automation for internet exchange points as well. Really cool stuff. Anything else you want to say about yourself with respect to introduction, Chris?
That's good highlights for sure. Yeah. And I will say that working as a kind of backbone, carrier network engineer, we kind of separate like the customer edge and the core away from the peering and transit edge in a lot of companies. And so I know that I thought I knew BGP inside and out. I thought I really understood kind of how the internet works and how networks work. And then I founded IX Denver 10 years ago and realized that I kind of had no idea how internet exchanges worked or how peering really worked, which was wild to me. It was kind of eye-opening to be 10 years into my career and have a JNCIE and then be like, oh, wait a minute, like this little switch thing on the side there isn't as straightforward as you might think. So excited to kind of share some of that with folks and talking at a deeper level as well.
Yeah, I mean, for those that aren't aware, maybe you've only been inside a router and configured a BGP pairing session, and maybe you thought that this was going to be about router configs, but pairing, obviously a technical term in the BGP specification, used to configure and exchange routes. It could be between two autonomous system numbers that are your own, or it could be between two autonomous system numbers where one is a supplier of internet to you. But for the purposes of this conversation, we're talking about exchanging routes, uh, where I give you routes to my customers and you give me routes to your customers. So it's much more constrained, and this enables us to talk and exchange information only between our networks. So where there's common value, and that is really the foundation of what we're talking about when we say peering and interconnection. There, of course, are a lot of variations on this. You can have a peering relationship that's quasi-commercial. It can be paid. It can be like free peering, completely free peering. When we do interconnection at scale, where we're using dedicated connections between networks, we're often sharing costs. But also sometimes there can be pairing where there's also partial transit involved. It's a crazy world out there, but let's rewind by way of introducing this topic and go back to 1994, a long time. And, unfortunately, I'm old enough to remember that. In 1994, there, there was a little bit of peering taking place, but the internet was still centered around the National Science Foundation backbone, so that funded by the U.S. government. And that contract was owned by a company called Advanced Network Services out of Ann Arbor, Michigan, and they operated a national network. And if you were lucky enough to talk ANS.net into peering with you, it really wasn't peering in that sense. They actually gave you full routes to the whole internet. So you had full internet connectivity everywhere just by pairing with this one backbone. And that was great until the National Science Foundation decided that this internet thing looks like it's going to have legs, and we should kind of let the commercial world take over. And so they started this. There was at that point in time there were, and when I say that point in time, I'm talking like early 1995. There were two exchange points that I'm aware of. There was May East, which was a FIDI switch operated by MFS DataNet in a parking garage in uh, Tyson's Corner, Virginia. And there was the KIX, Commercial Internet Exchange, operated out of the data center in Palo Alto, the Palo Alto PAIX. And that was a separate internet exchange. I'm trying to remember the name of the actual data center in Palo Alto, but there was the KIX. And in any case, the National Science Foundation kicked off an RFP to have people operate three new exchange points. And so that was won by Sprint out of Pensacola, New Jersey, the Sprint NAP, the Ameritech NAP out of Chicago, and the Pac Bell NAP out of the Bay Area. And two out of the three were operated on ATM, which was a lot of fun. And but MFS DataNet started May West, and then I actually started just a local exchange point in Tucson called the Tucson NAP that was frame relay based, which was, as far as I know, the first ever regional exchange point where the intent
Cool.
was not for national providers to exchange traffic across their whole network, but it was for local ISPs to exchange traffic locally and keep it local. Um, but this is really important because this transition from this, even though the internet was designed to be decentralized, it really didn't truly become decentralized until it moved away from a central core backbone, and internet exchange points started popping up, and then Equinix popularized the carrier neutral data center, such that and that was kind of important too because MFS DataNet, or MFS, was operating exchange points, but then they were also the access supplier. So like if you wanted to get to May East, you had to buy access from MFS to get in, and it was not very great quality and it was overpriced. There wasn't a competitive environment for people to get together and exchange internet traffic. So 1995 is like a really exciting time to be operating a national backbone because of all this transition. But since that time, there's over 1,000 internet internet exchanges, public internet exchanges worldwide. And on top of that, probably thousands of data centers where people will do private interconnection between each other. And this is the internet. This is the fabric of the internet, is this decentralized set of networks and fiber routes, and the fact that they get together in all these locations and exchange traffic is what makes it real. It's what makes
Yeah,
it
it's really interesting. It's one of the things that has always attracted me about just the idea of the internet in general, right? Is, internet is short for internetwork. And so as you're explaining there, Dave, right, what we're talking about is individual networks, most of which are commercially run for profit for some reason. And in order to provide any value, though, they have to connect to each other. And so it's this really intense form of co-opetition, right? There's cooperation and competition where maybe you're going after the same customers, but you also have to exchange routes to keep the internet working. And we've seen where that breaks down sometimes. We've seen some big, there's kind of a couple at least famous de-peerings where two big networks decided not to exchange routes with each other, and heck breaks loose, and it causes a big kerfuffle. But in general, everyone kind of connects. And so I think of, peering and interconnection in the frame we're talking about as kind of these knots that tie the internet together, because it's, AT&T connecting to Verizon, connecting to your local ISP, connecting to a data center network, connecting to the content network that you want to talk to. And so, I just find that aspect of it really, really interesting. The fact that, we're basically tying these networks together at these specific physical locations through fairly simple networking, but because you're negotiating between two organizations, it can be much more interesting than just a BGP config might show.
exactly. So let's. What do we mean by IP transit when we talk about that, Chris?
Yeah, so I think it's good to I think the easiest way is to compare and contrast it with transport services, right? So a transport service is typically an A to Z or A to B connection, right? So if you're buying a 10 gig or 100 gig wave between two cities or between two data centers, and basically it's typically a layer 2 service or even lower, and you're just transporting bits for this one customer, right? So you might buy dark fiber is technically transport services as well, but maybe you have a pop in San Diego and a pop in Denver, and you want to just be able to transfer traffic between those two. So you might go to Zayo or Lumen or somebody and get transport services to carry your bits between those two facilities. There's lots of ways you can use that, but it's really just carrying the bits for you. Then transit, on kind of the other hand, so to speak, is actually providing access to the entire internet. And so when you buy transit services, this is often called internet service, right? There's like DIA, direct internet access. If you're buying it commercially on a large scale, it'll often be called transit services. This is something you can buy from your local ISP, whether that's a cable co or a telco or a WISP or whatever. It's also something from the business side you can buy at a data center from a big carrier. And so the idea of transit is that they're giving you access to everything they can connect to, and their job as a network provider or as an internet provider is to have access to everything. Now, what's interesting about transit services, I think, is that whoever you're paying for transit is probably not delivering the bit to the very end. You're going to hand it off to, let's say you buy service from, one of my local providers here is Charter. So I hand my internet service at my house to Charter. Charter doesn't have networks on the entire globe. So if I'm reaching out to maybe a content provider that's based in Europe, or somebody's website that's hosted in Africa, or whatever it might be, Charter is going to carry that to some kind of peering place and hand it off to another network. Now that may be that they're paying for transit themselves. It may be that they're doing some kind of private network interconnection or publicly peering over an internet exchange. Like we'll talk about more in this call today. But so that's kind of the difference between transport and transit. And so transit is all the internet routes, and it requires the provider to be able to deliver that even across other people's networks.
Right. So Charter, I think, is probably what we would call a tier one at this point, where they've gotten large enough to where they've been able to justify peering with enough different people to where they don't have to buy transit from anyone. So they peer with AT&T and Verizon and DTAG and France Telecom and enough different global companies to where, when you're a customer of Charter, you can get to any other major backbone in one hop, and then that backbone may have one or two or three hops to get to the end destination. But it all works. Typically, if I buy from an ISP and you buy from an ISP, and we make a phone call where the traffic goes directly between us over the internet, maybe my ISP is buying from Hurricane Electric and your ISP is buying from Cogent, and Hurricane Electric and Cogent peer. And so they exchange traffic. And so that peering connection is what makes that all work. Neither Hurricane nor Cogent have to buy transit. But in some cases, someone does. They have some transit and they have some peering. And that's going to be a big topic today. So, when does it make sense to peer and why would I want to do it? Well, as cheap as transit is, if you have a lot of traffic, it still is a pretty big line item in your P&L for your network. And the networks that I work with, transit can still add up to hundreds of thousands of dollars a month easily. And so peering is a strategy for reducing that bill. And when we identify someone else, some way to lower that transit expense, that comes by identifying a network that we have a place in common that we can meet and that we can establish some kind of peering relationship, either over a public exchange or privately over a dedicated connection. And when we do that, the traffic shifts off of transit over to this less expensive connection. And that's what we large carriers have always referred to as being disintermediated, which when my wife saw the post on social media, she's like, "That's not a word." I'm like, well, I don't know, but I've
Been
been
used
using
quite a
it
bit.
I've been using it for decades, because that's what happens. We disintermediate our transit provider by finding people to peer with, and it basically means that we find a route around the transit network so that these middle mile carriers that typically get compensated to exchange all this traffic and to carry things, they're not in the picture anymore. We have a direct route, and that's fundamentally what we're going to be talking about today. Is um, I think now you understand why you would go about doing that, but the next piece of the question is how and where. And you know, don't fall into the trap of going somewhere where it actually costs you more than if you just bought transit. I mean, in the United States, cost of transit, depending on how big you are, even if you're relatively small ISP, you should be getting transit at sub 10 cents a meg in the United States today. And if you're really big, you're getting quotes for like 2 cents a meg. I mean, it's like ridiculous. We're already down to it's turning into wholesale voice where we're starting to talk fractions of a penny when, when we're negotiating transit deals, which is crazy. But and that can actually still be for a lot of people the cheaper option compared to trying to go out and peer. Let's see. Just looking through my actually before we move on to the next topic, Chris, let me point something out to folks. If you have a question, there's three different ways you can ask a question. You can just type it in chat, and hopefully Chris or I will see your question and we'll bring it into the conversation. Option number two, you should have a like a call in button on your screen. I haven't been a customer of Riverside, like an audience member on Riverside before, so I can't remember exactly what it looks like, but it should be like a call in, and that will kind of let you join just like a Zoom call, and you can ask your question via audio, or you can ask it with audio and your video turned on. Just know that if you decide to turn on your video, that you will be featured in the live in the replay on
Yeah,
YouTube
it's
um,
forever. The internet's forever.
forever until there's a what's it, a copyright takedown.
Yeah, 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 yeah.
So three different ways, and we encourage you to ask questions throughout. We don't want to Chris and I, we don't want to move too fast and leave anyone behind. So please do ask your questions. And
Absolutely.
we would love to feature your question and the answer as part of part of today's webinar. So next, we're going to just lay the groundwork in terms of helping you understand the requirements for peering. So
Real quick before that, Dave, I just want to jump in on one thing because we've talked a little bit about the cost advantages of peering, and I know we'll get more into this later. But I just want to point out that there are potentially other advantages other than just cost moving to peering. I mean, we'll touch on that, but we were talking about the financial aspect, so I just wanted to point that out.
yeah, we're going to talk about that a little bit more later in the webinar, talking about the reasons to peer. So we're gonna get into that too. But I'm gonna hand it over to you. We're gonna talk about some of the requirements to peering. If you're not sure what you need, what do you need in order to peer, Chris?
Yeah, so I think the big thing here is the equipment and the knowledge to do it, and what I mean by that is when you start doing peering. So depending on where you're at, kind of in your network, size, scope, scale, life cycle, you may be just getting your transit may just be internet service where you're getting kind of a default route from a single provider. And in that case, you may not have a router that's even capable of BGP, or maybe not one that's capable of taking full tables. And full tables means getting all of the routes of the entire internet loaded onto your router so that it can make choices between multiple routes. Now, once you've gone to multiple transit providers, you're typically taking full routes, although a lot of people do have one or two transit providers or even two or three transit providers and still use a default route. And so they're not actually working on a router that's capable of taking full tables. The table continues to grow, the number of routes, and that takes up RAM on the routers. And so having a router that can hold full tables is a pretty big deal. Now, you don't necessarily have to do full tables to do peering. There are definitely ways to skirt around that because BGP prefers more specific routes. If you're taking default routes from two transit providers and you add a peering connection where you're getting their local or regional routes from your peers, those are going to show up as more specific than the default. And so you don't necessarily have to have full tables on a router, but you definitely need one.
I recommend it.
Yeah.
I definitely
it's best
recommend,
practice.
like, if you're going to get into the peering game, I recommend getting routers that can carry a full table and multiple views. The first ever national backbone that I ran, we had it was running on Cisco 7010s, and we only had two of them for the whole network. And everything, all of the other edge routers on the network were 2501s, which some of them only had 4 megs. I'm not talking gigs, megs of RAM.
Yeah. It's not very
And
many routes.
in order to run BGP, sometimes they had to completely turn off OSPF.
Yeah. Fun.
And obviously, if I got a version that had 16 megabytes of RAM, then I could put a full table in it.
At
And
that time. Yeah.
then
Yeah. That won't work anymore.
I was rocking and rolling. But I mean, I recommend it. I mean, the amount of hacking that you have to do when you have one of these smaller devices, like let's say you're trying to use like a $800 Arista top of rack switch that you got off of eBay, that's like 10 years old. That's not going to be a good choice.
Right. Right.
It's there's still plenty of really good used equipment that you can get on eBay if you're cost conscious. Just get one of the bigger models that's got RAM that's designed for doing multiple routes, and use that.
Yeah. So that's a big part of the requirement is you need something that's going to do BGP at the level you need it to do. And then of course you need either yourself or staff, right, who can actually configure that BGP, because again, if you're going from kind of a couple of default routes to taking full tables and then messing with local preference and prefix appending and kind of doing traffic engineering, which is probably what you're going to want to be doing in order to take full advantage of peering, you need to have a pretty in-depth knowledge of BGP and how it works. And the more you understand BGP and can get into med and local pref and prefix appending or sorry AS append prepending, and then get into things like using communities to steer traffic and that kind of stuff. The more you understand that, the better you're going to have, the better you're going to be at doing that traffic engineering. That's going to really maximize the offload of transit onto the peering network and be able to do failover, right? Because while we may not have the May East router in a parking garage anymore. not all IXs are created equal, and depending on where you're at and where you're connecting, it still may be kind of a broom closet situation.
Well,
Even the
let's
six, right, the biggest internet exchange in the U.S. was in a broom closet for quite a long time.
yeah, let's so in the interest of moving on, I want to make sure that we have a chance to review and talk about the ROI calculator. But so let's move into the process piece here real quick. How do you identify potential peering locations and peering partners? Do you want to maybe pull up your browser real quick, Chris, and take us over to peeringdb?
Sure, I can do that. Let me load up peeringdb first.
Quick show of hands. Type a 3 in chat if you are not familiar with peeringdb.
So this is peeringdb. No one's raising their hand to admit they don't know what it is.
Well, there is a delay between our discussion and the live stream, so it could be
All right.
could be that.
Yeah. Oh, this is here. There's also some tools that kind of pull data from peeringdb and make some of this a little simpler. But basically, what you're going to do, obviously, with IX Denver, I'm going to look at Denver first. So I'm just going to type in Denver. It does a pretty good search these days. And so what this is showing me is the internet exchanges that are in Denver, the networks that are in Denver, and the facilities that are in Denver, as well as the organizations that run them. And so what I usually do is, not all networks have to be actually homed in a city. So I usually start with the exchanges, actually. And so in Denver, and I happen to know this, like there's 5 listed here. Denver IX is not a real exchange anymore. They've shut down and they need to be removed. NE2 Denver is the CoreSite exchange that they bought about 15 years ago or so. It was the Rocky Mountain Internet Exchange before it was bought by CoreSite and became NE2 Den. Equinix only has a couple peers. Mega IX only has a couple peers, and then IX Denver is pretty much comparable size with NE2 Denver. So I'm going to look at IX Denver just because why not? And by clicking on that, I can see the number of peers and connections and some things. But what we're really looking at is this list over here, the peers at this exchange point. Because now I can look and see all of the networks that are connected at IX Denver. And so, again, the only reason I would be looking at this is if I'm in Denver already and I want to do peering in Denver. And so now I can see, okay, well, what's possible? And I can look at this and I can see what networks are here that I might want to peer with. And so if I know that I spend a lot of traffic to, maybe I'm a retail broadband provider. And so somebody like Riot Games is going to be important for my users because they're serving game content. Otherwise, in other situations, maybe folks like Quilt and Akamai are going to be important for CDN and pushing other content down. True, I might not be in Denver yet, but hopefully I already have plans to go to Denver. That's a good point, Guy. You're exactly right. And what I can do is kind of pull this list down. And then what I would probably do is also go back and look at NE2 Denver as well, since they're the other big exchange, because they might have some peers that, not everybody's going to be on both. And so there might be specific autonomous systems you can connect to over one over the other, and you create that list from there. Now from there, I don't know what you do, Dave, but, I honestly start with traffic analysis. And what I mean by that is you can use SFlow data from your BGP router that's already doing the transit, and you can see what ASs your traffic is going to, and that'll help guide you.
Yeah,
That's going to
there's
be huge.
definitely 2 ways you could approach this, right? So you could say, okay, well, it appears that IX Denver is the best place to go in Denver, and not that we're biased, but of course it is. And we could then build a list of all the people that are peering there, and we could go into our NetFlow tool, and we could put every single ASN in there, and we could figure out, okay, well, if I start peering at that public exchange, this is likely the amount of traffic that my network would push there. And that's pretty important that could be important for sizing, or just cast a really big net, say, okay, well, and then build maybe the same list for the other exchange points that are in Denver, and see what the comparison is. And obviously more traffic means more traffic pulled off of your transit. So if that's your primary motivation is cost, that's good. But also, if your motivation is performance, that's also probably a good indicator that you get the most bang for the buck going to the exchange with more traffic. But to your point, Chris, what I am usually doing is I'm running an analysis on my transit connection itself with NetFlow, and I'm identifying either the depending on what business I'm in, either the top sources behind that transit provider or the top destinations behind that transit provider, and then I am going and I'm looking for places that I can peer with them. And so I might say, okay, well, um, let me pick a random example, like say ZenLayer. Um, maybe they're a pretty big source of traffic behind my transit provider, and I start to and I look them up, and I'm like, okay, well, where are they relative to where I am, and where could I meet them? So I'll go both ways, but usually, like, I'm trying to get the biggest bang for the buck in lowering the transit cost, and so I'm using NetFlow to identify my top 5 peering targets, and then I'm using peeringdb for research to figure out how I'm gonna solve for connectivity with them.
Absolutely. And then, once you've
We have another comment here on the chat here. I've seen a graphical tool that shows connectivity, but I can't remember what it was. Barry suggests maybe Kentic. Um, it could be Kentic. So Kentic actually. So first of all, rewind a little bit more. PeeringDB has an API, and I have I've actually I need to do a tutorial on this, but you can actually use that API to suck information into Excel, and then you can create a file that you can import into Google Earth, and you can get like a geographic representation of every peering point in the entire world. That's kind of a fun little thing to do. So that's one way you can do it. Kentic will show you the NetFlow, and it's got a PeeringDB API integration as well. So it will actually like help you figure out some of this stuff without you having to go back and forth between different screens. Um, and BGP tools is I forget if that one what kind of graphical capability that one has, but Harshava is asking if the API is a new feature. She only discovered it recently. It's actually not new. It's been there for, I couldn't say if it's been there since day one, but I used it for the first time about 6 years ago. So I know it's been there a while. But it's really valuable, that API. There's all kinds of uses and capabilities for it. And I love the fact that there are software vendors out there that now feel comfortable enough with it to integrate it into their tools, because that it just gives us even more incentive to make sure that our information in PeeringDB is up to date. The more up to date it is, then the more useful it is for everyone that uses it, and then the more tools it is. So I guess I'll remind everyone, if you do peering and if you are in a data center, make sure you put your network information in PeeringDB so that people know you're there.
Yeah. And then that leads to kind of step two, which is, again, another reason that PeeringDB is great is that people can self-identify what their peering policy is. And so folks who say that they're open are basically saying, hey, if you come ask us to peer, we will peer with you. And then people who are selective, there's some kind of constraint. There's going to be some level of negotiation. They're going to want to see, you're going to have to show them that, S-flow data or NetFlow data that shows how much traffic is going to go between you guys. Or, maybe they have restrictions on, up to so much traffic over an IX. And if you're above that, they're going to want to do a private network interconnect, a PNI. There's all kinds of different things that might go into selective. Selective doesn't really tell you what their choice metrics are. It just says that it's not going to be a default yes. And then I think there's even, maybe it's just open and selective these days. Is there, but that's good.
Open, selective, and
Isn't
then
that restricted?
yeah, restricted is the other
But
one.
you don't see that very often, luckily, these days.
That would be like, AT&T, DTAG.
Comcast, yeah.
Yeah. It's they should just they should swap them out for emojis, and restricted should be an emoji of like, the middle finger.
Exactly. Yeah. I like it. I like it.
Like Mike says, denied.
Yeah.
Totally. Like, yeah, that's their autoresponder, if there even is one. It just goes to dev. The peering email just goes to dev null.
And then if you notice this little icon beside open, that little icon, it's basically like a mesh network with a circle. It's kind of a hub spoke, but the hubs are all connected. Anyway, that little icon indicates that they are a peer of the route server, which is another interesting little bit here. So route servers are offered by many internet exchanges, not all, but a lot of internet exchanges have a route server. And basically what happens is anyone who wants to BGP peers with the route server. No traffic is ever exchanged with the route server, but what happens is because everyone who's peering with the route server provides their routes to the route server, then anyone who peers with the route server gets all of those routes. And so a lot of times, half or more of the participants at the exchange will be peering with the route server. And so if you just connect to the route server, there's no negotiation, there's no paperwork. You just connect with BGP to the route server, and all of a sudden you're peering with a bunch of folks over that exchange. And so
sometimes there is paperwork.
Sometimes.
And it would often be called an MLPA or a multilateral peering agreement. Basically says that, in order to peer with the route server, you agree to, not filter routes or not try and restrict your announcements to anyone. You automatically is basically an all or nothing. It's kind of implied anytime you peer with a route server these days, but there are still a couple of places that will make you sign that multilateral peering agreement. Like, as I recall, Cabase down in Buenos Aires made us sign an MLPA when one of my customers showed up there to peer. So you'll find that the alternative is when it's not like a multilateral through a route server, it'll just be called like a bilateral, meaning just two parties. And most of the internet is built off of bilateral peering agreements, by and large. Speaking from a traffic perspective, um, I'd say probably like most of the, like numerically speaking, most of them are like handshake deals. But in terms of quantity of traffic exchanged, there's almost always a contract that governs that exchange.
Yeah. And I think there's often again, this is not hard and fast rule or anything, but just the way things normally work for a lot of peers is, you may go in and connect to the route server and have this kind of multilateral session where you're connecting to everybody. And then if one of those peers that you're connecting with via the route server, you start to see a lot of traffic between your and their AS, then maybe you'll set up a bilateral peering session where you two peer directly, but over the internet exchange, where you play basically the difference is instead of exchanging BGP routes with the route server, you're now exchanging BGP routes with their router. That's also how you connect to folks on the exchange who aren't on the route server. Is setting up a bilateral session where you're basically BGP peering between each other, but over the internet exchange fabric. And then in some cases, some networks will choose to move that to a private connection once that gets too big. Maybe they don't want to fill up their internet exchange port with 50% to one AS, and so they'll pull that off and do a private network interconnect and keep the peering port free. So that seems to be a graduation. You don't always go through all three steps. Sometimes you jump right to the third one. Sometimes you stay at the second one. Sometimes you stay at the first one, but there is kind of a graduation there as well. Then
we have a comment from Guy. He's just saying that HKIX, Hong Kong Internet Exchange, used to be an MLPA, but he's not sure that they still are. I think a lot of people are removing the contracts because they turned out to be unnecessary paperwork, and of course, anytime you get lawyers involved, it tends to slow things down.
And makes things more expensive in a lot of cases.
And that too, yeah. Well, we should probably move on to reasons to peer, drivers behind peering.
Sure. Well, real quick, I mean, just finishing that out, just to kind of close the loop, I guess, right? Once you've got that negotiation done, you're actually going to physically connect to the exchange fabric or set up the PNI and the cross connect to that other network. You're going to set up BGP, and then you're going to monitor it over time, as we talked about, to maybe change things if needed, increase the speed of the port or whatever. Yeah. But yeah, I think we should dive into reasons to peer. And really,
then we're going to get into the calculator.
Yeah. This will lead us right into the calculator,
which I hope everybody finds really valuable.
Yeah. I mean, for me, Dave, the big ones are it's really somehow performance related or somehow cost related, and hopefully you're getting both and you're firing on all cylinders. as you might have guessed by now, by understanding kind of how peering works, there are non-financial advantages to peering, which are you're exchanging the traffic directly with your peer, right? And so, for example, let's say I peer with Netflix over the internet exchange, and if I do that, then what that means is there's no one. We've disintermediated everyone at that point, right? To use Dave's earlier 10-cent word, because instead of paying a transit provider who maybe pays another transit provider who peers with somebody who gets paid by Netflix, you're going through all these other networks. Now you're connected directly to Netflix, and that's one example, right? That, whether it's any other CDN or a gaming server or cloud software, right? Maybe you want to peer directly with somebody like Salesforce or with Microsoft or with Google if you're using their productivity suites, and that's going to give you direct access to their network, which can be nice. It means that connection is no longer subject to outages in a carrier that you're not in control of. It means you probably lowered the latency, and it also means now you have two paths to that peer because you can go over the internet exchange or the PNI to the peer directly. You still have the transit as backup there, and so you've definitely increased the robustness of your network as well. So I think there are a lot of reasons to do that. In the ISP world, not that this is necessarily common, but level 3 became a dominant carrier by just peering the heck out of everything they could. They became the most peered network in the world and kind of overtook some of the carriers that were the kind of default tier ones by just peering. And then Hurricane Electric has kind of come along and done the same thing more recently, where they would just have this open peering policy and peer with everyone who would let them. And they kind of really built a really big routing table where they didn't need as much transit by just going really hard on peering. Whether or not that strategy would work again now in 2025, I don't know. But
Well,
there are kind of ways to
it's always a
expand your reach.
balance when you're building a network, right? Because if you peer with everyone, then you can't really sell to anyone.
Yeah, right.
There's a balance, especially like if you're in the business of selling transit. If you're in the business of selling residential service, then having a completely open peering policy makes sense, obviously, because people that are at home are not going to be peers. You're not cannibalizing your own market opportunity by doing that. But if you're in the business of selling transit, it's always a trade-off. Do I like you spot like, okay, well, here's like the single biggest source ASN behind my transit provider. I'd really like to lower my cost, but what would be even better is if I could go sell that person, and then I put them behind my network. And you talked about you dropped a phrase, the most interconnected network, and there used to be a report called the Renesas Baker's Dozen way back when that got bought by Dyn, which is now part of Oracle, I think, and they don't really do that report anymore. Really, all we have now is CADA rankings. Um, Chris, you want to type the URL for that in chat while I'm talking, but
Yeah.
CADA will have that AS rank, which describes the amount of interconnectedness that you have. And a common misconception is that is mostly around peering. It actually weights the number of prefixes that you advertise or your customers much more highly than it ranks the peering that you have out there. So doing a lot of peering is not going to increase your ranking nearly as much as picking up one decent customer. One decent customer that has a lot of prefixes that represents a lot of IP address space, that's going to cause your CADA AS rank to really jump.
Yeah. And
Uh,
then that comes into another topic, which I don't think we're going to go into very deeply here, but it's probably worth mentioning, which is there's kind of been over the last few years this resurgence of this idea of paid peering, which is kind of the same thing, right? Where you're taking somebody who wants to peer with you and saying, okay, sure, but we're not gonna do it settlement free. We are gonna make you pay for those routes, even though you're not taking a full table. And there are carriers there's different carriers who do that to different degrees
I don't think
today.
that's ever died off, Chris.
Fair
In
enough.
fact, I just saw a post this morning. Like the king of paid peering is DTAG. For those not familiar, that's they were the PTT, the original telephone company in Germany. And although paid peering was not invented by DTAG, that award actually goes to none other than John Curran while he was at BBN. John Curran's the current CEO of Aaron. The apparently the consumers in Germany are finally banding together and saying that DTAG's extortionary practices with respect to peering and forcing people to pay them to peer is actually bad for the people of Germany. And so they're fighting back finally after 25 years of this practice. This is like a really good podcast topic that um, is maybe a little bit off topic for this webinar, but
You can just go Google network neutrality and get some of the debates from a few years ago.
yeah, there's definitely it's still an ongoing debate. There are still telephone companies that have substantial market presence that when they haven't like learned about this practice yet, and they think, well, gee, this would be a great way to make some extra money. And those are always the most difficult people to work with. Anytime somebody is putting, I mean, profits ahead of um, product quality, you're going to have a difficult time talking to them about pairing. But let's go back to performance drivers. So, I well just jumping off of this example with DTAG, or jumping off the example of someone like Comcast, who also has a restrictive pairing policy. Um, See previous emoji that we talked about in the call. Uh, there are plenty of fiber to the home providers that are taking a different approach. They're not trying to leverage their customer base as a monopoly in order to get a double-sided payment model where content has to pay them to get access to their customers. They're building based on this idea of quality.
Yeah.
And go and look at Comcast's last quarterly earnings report and see what they have to say. They're getting their asses handed to them, absolutely handed to them, uh, from new entrants into the markets that are stealing customers from them, and rightly so, because of the way that they have operated their network. I mean, they have done some really nice things in terms of automation, and they've they've they have made a lot of effort to improve the quality of their customer service and everything. And I think they're underappreciated for some of those things, but certainly their approach to peering really says a lot about how they think about their position in the market and how they want to leverage it. So you can differentiate yourself from the people like Comcast and Charter by taking a different approach to peering and having a more open policy. This is not always going to lead to savings, right? I think that's what Chris and I are trying to talk about here, is that the ROI calculator can be used in two ways. One, if you want to lower your transit bill, comparing the cost of pairing to transit to understand when an opportunity is going to enable you to lower your transit bill. That's one way to use the ROI calculator, but maybe you're actually willing to spend more than you do on transit because quality is so important to how you're building your product and your position in the market. And if that's the case, you can still use the ROI calculator to determine when one internet exchange point or data center is going to be more cost effective than another data center. So it can be used for comparing different peering opportunities, or it can be used overall for just determining how to manage and lower your overall network expense. So I think I've just segued very nicely into the ROI calculator. Chris has it up right now, and why don't you walk us through some of the calculations that are in here so that people understand how they will be able to use this themselves?
Yeah, absolutely. So this first tab I'm showing here is called the IX comparison, and it can be used for that, or it can just be used for general kind of thought experiments as well on just one IX. So what we've got here is, right now it's set up with three IXs. You could obviously copy these and expand it out if you wanted to compare more. I tend to look at three or less exchanges. There's usually three or less kind of major ones in each market that I'm going to look at. And then one of the things to point out before I get into these is, the amount of traffic you think you're going to push to the exchange is of paramount importance. because the one thing that's different about peering either at a PNI, whether it's private network interconnect with another AS directly, or over an internet exchange, is that you pay for the port, which is great in that you're getting all you can eat all the time. It's also potentially not great because if you've got a 100 gig port and you're only pushing 5 gigs of traffic over it, you're paying for a 100 gig port, right? So you're not charged based on 95th percentile or anything like that. It's just the port cost, which, like I said, it's a double-edged sword there. So that traffic level matters. Now let's work this out. Let's say, and again, it's most familiar to me, so I'm going to go with like IX Denver. If you want a 100 gig port, it's going to be $1,500 a month. The cross connect in that building, I think, is something like $350, and I think they do a one-time fee of the same amount. So that matters. Now, the transport cost goes back to this question of, are you already in this data center? Are you already in this carrier hotel or not? If you've got to get connection into it, it's going to cost more. Let's say we're already in this one. And co-location, let's say we already have a router in the rack, so there's no cost. Maybe we need a new 100 gig optic, and we're going to go with the name brand, so it's going to be $1,500. So my 5-year total cost is almost $113,000. And if I'm only pushing 10 gigs of traffic, that means I've got an effective rate of 19 cents per megabit per second per month, which compared to the transit prices Dave was talking about at the beginning is at least double what you're paying for transit, if not a whole lot more. But if I push that up and I'm pushing 60 gig, then things change. And now all of a sudden it's 3 cents a megabit per second effective rate, which is a lot more competitive with what you're probably paying for transit, right? And then I can also use this spreadsheet to do the same thing. Let's say I'm looking at another one. Let's say I think DKIX charges like $3,000 for their port cost. Let's say the cross connect in whatever data center they're in. Obviously, this wouldn't be Denver anymore because there's no DKIX there, but just throwing some numbers in there. But let's say I need transport to get to this internet exchange. Maybe it's $1,500 a month for a 100 gig wave, and I'm not in there anymore, so I need colo. And I have to actually put a some kind of device in there. Let's say it's $25,000 to put the device in there. And now, we can see that on this exchange, I have an effective rate of 3 cents, whereas on this exchange, it's 10 cents. And then maybe there's another internet exchange where
Now in what circumstances will we need transport, Chris?
basically, so I mean, there's some shades of gray here, but generally, anytime you are not already in that facility, right? So, and again, I'll use Denver as an example because it's the one I know the best. 910 Telecom, 910 is the address of the building where the carrier hotel is. If you've already got a POP there, right? If you already have a cage or a rack in that building, then you're only a cross connect away from the exchange that's also in that building. But let's say instead you're across the street at 1500 Champa, and that's where your POP is, or maybe you're across town in some other data center, then you're going to need to get to the carrier hotel where the internet exchange is, and that's going to take transport, right? Or maybe you're not even in Denver yet. Maybe this is you're building this out for the first time. Now the reason I say it's a gray area is if you're building out Denver, then I don't know if the whole cost of transport and the whole cost of co-location and the whole cost of the equipment is actually going towards the IX, or is it really going towards this build out you're doing? And that's why there's some gray area
bunch
there.
of different design considerations for sure. It could be that, and this is often the case, the building where the best data center is full.
Right. That can happen
You
for
have
sure.
You have to colo next door or across the street or down the street, and then buy transport into the into that location. Mike points out Filigree Court, which is Ashburn, Virginia. That's definitely the case. Maybe although Equinix will charge you they'll let you cross connect to the IX from any of their data centers, but maybe you're in the NTT Raging Wire data center or something like that because the pricing was good. Now you've got transport to get over to the good internet exchange. So that's an option. I wanted to mention too that let's say that let's say you bought a port from DKIX in one of their locations, and then they were offering remote peering to get to, say, Frankfurt, which is one of the biggest internet exchange points in the world. So you're in New York City and you want to get to Frankfurt and peer there. Well, they're going to charge you a transport cost to get from New York to Frankfurt, and then they're going to charge you um, the port fees for the Frankfurt Internet Exchange. So you would just, if you were using this to evaluate remote peering, you would drop that bandwidth charge from DKIX into this transport cost
Absolutely. Yeah.
section.
Yeah. And then you can also compare like two different build styles. So let's say that BGP router, let's say even used, it actually costs $50,000. And then the other option, and I'll make all these other things the same here, but what if, instead of dropping in a full-blown router, because you've already got a router at your main POP, all you need is some DWDM equipment. And so you still have the transport cost, but now maybe you're coming down and this is only, $7,500 for a ROADM or something on a ring there, where and now you're only paying for a quarter of a rack. And so you can bring that cost down. So now instead of 11 cents for the full router build, you're looking at 9 cents is the effective rate with the DWM equipment. So you can play with kind of different scenarios here outside of just which exchange you're choosing, but also kind of how you build in and compare those costs.
Well, now let's show something else here, Chris. So we have a couple different price points here. We got 3 cents, which is for probably a lot of the people on this call, 3 cents a meg would result in a reduction in their transit bill. 11 cents, 9 cents, questionable if you're going to see any reduction in your transit. And in fact, in the long run, because these cross connect fees, the monthly cross connect fees tend to go up, not down, as the data center gets more dense, and the value of interconnecting inside that data center increases. These cross connect fees go up. Your only hope for really reducing at that point is increasing your scale considerably, like going from 100 gig to 400 gig, which quadruples the amount of capacity. But you got to have the traffic, and that's where we can do a little sensitivity analysis here on these numbers by modifying that megabit per second of traffic, right, Chris? So if it turns out we only have 20 gigs of traffic that we think we can peer off, so we go up there and we change that to 20. Look at how these numbers shift. That cheap option 1 at 9 cents a meg, that doesn't look so great anymore. That's more expensive than what you can get buying from Cogent, that same amount of bandwidth, the 20 gigs. How about option number 2, 32 cents a meg? Well, now we're looking at 4 or 5, even 6 times what you're paying for transit in that model. So what this tells you is that, hey, buddy, don't feel bad, but you're not at the scale to where you're going to be able to really leverage peering. Now, again, if the price is similar, if the cost is similar on a per meg basis, and quality is that important to you, then maybe you move forward with this. Maybe you've got a growth plan that says that your traffic is going to quadruple over the next year, so you can afford to take some risk. But if you're on a shoestring budget, or you're really, really tight on money and managing your P&L very, very closely, this is going to help you figure out if this investment is going to pay for itself in the short term, or if it's more of a longer term play.
Yeah, we got a comment from Guy, and he's 100% right. So he asked about the colocation costs and said that for many non-neutral internet exchanges, if you're not in the ecosystem, if you're not in the building, the data center operator will force you to take a cabinet in order to connect to the ISP. And so definitely that colocation cost can be forced upon you. Maybe you can't do remote peering, right? In some cases, you might be able to get a circuit into the building and have the transport provider cross-connect directly to the IX and not have to do any colocation in that building at all. In other cases, that is not an option, and you have to take space. It's one of the reasons why I really enjoy having a carrier neutral and facility neutral exchange in the cities I operate, because then you can kind of meet them where they are and avoid any rent-seeking behavior by data center operators that might happen. I think that's a good look at this piece for now. And then let me show you another tab here we've got. So this is just looking at OpEx, and it's just an effective rate comparison. So, let's say Akamai is one of my targets, and I'm in a data center where the cross connect's going to be $375, and I've got 10 gigs of traffic. All right, that gives me an effective rate of 4%. But let's do that same one, and the cross connect is still going to be 375, but I'm doing it across an internet exchange, and they want, well, if I got 10 gigs of traffic, I probably got to go to a 100 gig port, or maybe I can do two 10 gig ports. So let's say
Let's just
it's
call it, like, if you're doing Equinix, let's just do Equinix to make it
yeah
simple and call it like $3,500 a month.
for the port for the IX port.
Yeah.
That sucks. Um,
I know. Well, compare that with like the community IX, like Florida Internet Exchange, which is
yeah,
only like $3,500 a year. Yeah,
right.
it's a huge difference, like a
Huge
10x
difference.
difference between a data center offered exchange point and one of the other companies.
Let's say they're in a more expensive. Let's say these guys are in Equinix. They've got like a $900 cross connect fee, but you're connecting directly, and you've got 60 gigs of traffic. And so you can kind of see, how this plays out, and you can do different scenarios here of just the OpEx side of it, right? Ignoring any new, colo or the one-time cost that might happen, and just looking at if I'm already in the building.
Let's do another scenario here.
Yeah,
Let's do like on row 5 where it says Akamai. Let's just put in MI1 or something like that for Miami, and then for the traffic, because we could theoretically aggregate Akamai and Fastly together. Let's put 70,000 megs, 70 gig in that column. And so, we can see here that actually the, like, even though it's more expensive per meg than the other options, it's nice because we get to aggregate so many on the same.
right. And you
And
may
now for
pick up
the
a bunch of routes off the route server or something that are going to add to that number. Maybe it's more than just those two, right? So maybe you're actually going to get 80 gigs of traffic, which is probably as hot as you want to run a port.
probably. And
Because you're going
maybe
to pick up a couple
Fastly is
extra
probably
AS.
not going to run at 60. If you're running Akamai at 10, Fastly will probably be more like 6 gigs. You can see that pushes that up to 15 cents a meg. So right off the bat, we're getting some numbers here based on cross connect fees that suggest that, on a 100, the really like 10 gigs is probably, we want to have at least 10 gigs of traffic on a PNI. Otherwise, we're probably not effectively using resources. And by the way, our partner peer is probably going to look at these numbers the same way, and they're not going to want to peer unless there's at least 10% traffic there. And if that number slips too far below that 10% mark or that 10 gig mark, then optimize. Now, Harshiva had a comment which is really good too, which is that, well, what if you can get the other provider to pay for the cross connect fee?
On PNIs, yeah.
Yeah, on a
If you
private
can be
connection.
Google and just make everyone else pay for everything.
Yeah, absolutely. That can go both ways. Um, there are definitely some content companies that are happy to cover the cross connect cost. I've seen cases where a global CDN told an peering partner on a peering request, you know what, we're terrible at ordering and provisioning cross connect, so we'll give you LOAs everywhere. Or no, we're terrible at generating LOAs. We'll just pay for the cross connects everywhere. Just give us
You
LOAs.
give us the LOAs, yeah, yeah.
Yeah. So that was a great deal for that particular network. But most of the time, people will share. So another thing you can do, you can factor that in here as an average. So if you don't have enough traffic for multiple 100 gigs in a location, but you have to kind of like trade. I'll do the first one, you do the second one, and maybe just for numbers, you just go in here and divide it. So you take if that's the case, if you're trading costs, trading cross connects, the take your average cross connect fee across the data centers that you would connect to that person in. So let's say it's $500 a month in one data center and $300 a month in another data center. Call it 800, and then divide it by 2, and go with a cost of 400.
Awesome.
So this is a nice way to just nothing explains. the concept of loading on a circuit and how that impacts your effective costs and what you're doing better than this model. And a lot of people get themselves in a trap where they just start doing P&Is like crazy. And there's two issues with that. One, a cross connect fee of $250 a month or $500 a month doesn't seem like that much, but they do add up. And you can get to a point where you're spending $1 million a year just on cross connects. So it does bear some attention to make sure that's addressed. The other thing that happens a lot with cross connects is the costs are not well managed. So, let's say you order, um, you're at 3 cross connects with a company, or let's say you're at 2 cross connects with a company and you want to upgrade to 4, you need to do another upgrade. And the choice is, do we do more 100 gigs or do we go to 400 gig? You're like, okay, let's provision a new cross connect and let's get a 400 gig up and running. And then you disconnect the 2x100s. Well,
Hopefully.
did you actually submit a disconnect order for those cross connects, or are they still sitting there and are you still paying for them? And a lot of times once they're disconnected from the routers, you forget about them, like literally out of sight, out of mind. And you can end up with massive, massive waste in your P&L just by not managing cross connects. So you definitely don't want to get into a situation where you start off on the wrong foot by ordering a cross connect that really you should probably just be at a public exchange and pick up the few gigs at the public exchange. And then you use your NetFlow analytics tool to look at who am I exchanging the most traffic with on the exchange. And when sometimes you'll find you've got like 40 gigs with someone at an exchange and you're like, oh my gosh, like, let's go ahead and do a P&I. We've got 40 gigs there. And then you alleviate all this room. Now you've got more growing room on the exchange and you can let the traffic build back up again until you've got another, 1 or 2 people that you identify as really good targets for pairing.
Yeah, and that's another way to use this form as well, right? If you look at something like that where you say, okay, do I want to add a second peering port or do I want to peel this one network off and go P&I with them, and that frees up space on my peering port so I don't have to pay the IX more, right? I think that's you can definitely scenario plan that out here.
Yeah. We just had a situation like that um, with one of Net Maven's clients down in Brazil where we went to the exchange point operator. We said, hey, we'd like to upgrade the 400 gig. And the 400 gig price was really good. It was like $4,000 a year or something like that. But they wanted a $15,000 non-recurring charge. And it turned out that there was a peering partner on the exchange that they themselves had like 60 gigs of traffic. And so we just P&I'd with that network. And the traffic on that exchange is now back in a comfortable 100 gig range. So that made perfect sense. The week after we had made that decision and turned up the peering, that exchange point dropped their non-recurring charge. So the economics completely changed, but such is life. We did what was best for the network at the time and no regrets.
Yeah. So now I'm going to jump into the full-blown ROI calculator here. And so this is kind of what it looks like blank. And what we basically
the interesting comment, Guy is laughing right here a little bit because he's multitasking on this webinar with his team who's working on a cross connect cleanup project. Classic.
Yeah, and Michael plus one's that there. Cross connects, forgotten cross connects are reality for sure.
Yep.
Yeah.
Yep.
So it's kind of looks like blank, and you can see, this is familiar. We've got the IX cost. In this one, we're doing 1, 3, and 5 year costs. Obviously, the longer ones make the NRC stuff less relevant. And the shorter ones make it more relevant. I like looking at all three, especially if I'm going to take a proposal up to a manager or an executive who's going to actually write that check and show them, the best, if I can get a 2-year positive ROI, that's great, right? If I have to stretch it to 5, I'll do that. And if I can do it in 1 year, that's kind of a slam dunk in a lot of cases. So, and we can fill these in. So the IX costs we've already looked at. The transit costs, let me jump to this example tab here. So we've got a few different columns here. You've got the commitment, because a lot of transit circuits will have a committed amount that you're going to pay for no matter what. And so on this first one, I'm thinking of these as 100 gig ports. The first one has a 20 gig commit. The third one has a 10 gig commit, and the second one there has no commit. The reason that's important is because if my traffic levels on that transit circuit are fairly low, even if I can shift all of that traffic off to the exchange, I'm still paying that commit. And so you've got to factor that in. Then obviously the actual monthly recurring charge per megabit per second. And then I'm looking at the average of, traffic on that port. And then this peering percent, this goes back to what we were talking about maybe a tool like Kentic. There's other tools that do it. There's also non-commercial tools. PM account, PM ACCT is a cool SFlow tool that you can kind of build your own stuff. Especially if you tie it into Grafana, you can get just as fancy a graphs yourself with just some dev time and instead of paying for it. But what you want to do is get the best estimate you can of how much of your current traffic can you shift over to the internet exchange. And you do that the ways we talked about earlier, right? Look at where the traffic's going, find if those ASs that are sucking up a bunch of traffic or shooting you a bunch of traffic are on the exchange or are available to do PNIs, and you put that percentage in here. So in this one, we're running 60 gig, or we're load balancing perfectly across all three providers. There's a little bit different pricing and a little bit different commits. And then because we're load balancing perfectly across all three, we think we can drop all three by 30%. And just assume that that's an informed guess there, right? And so we know that that's how much we can save based on the cost per meg and the percent we're going to peel off. We know how much we can save, and so then it's really easy math to add that up 1, 2, 3, or 5 years. And then what we're doing here is we're saying, okay, in this case, we've got one connection to an IX with a $1,500 port. There was an NRC on the cross connect, and it's $350 cross connect, and then we had to buy an optic. For some reason, that 100 gig optic was really expensive, and we got that cost. Now, maybe I want to do redundancy and I want to connect to another internet exchange, but I actually have to put some equipment in. And so this case, I've got transport costs, I've got co-location costs, I've got equipment costs, and that jacks the price up. So in this particular example, my 5-year ROI is positive, 3 years just barely negative, and 1 year is like 20 grand in the red. So, I need more than 3 years for this to come out in the green on this case. Now, if I decide, hey, you know what, never mind, I actually don't need redundant internet exchanges. Let me just connect to one internet exchange. That changes it drastically. Obviously, I just cut out a lot of cost by only going to one exchange and not having to deploy equipment. And now I've got a really high positive ROI just in 1 year in this particular scenario, right? And then obviously we can tweak these numbers and play around and kind of see how that plays out in different scenarios. And because you're basing this on as much information as you can gather about real costs and real traffic, it's going to give you a pretty accurate estimate. This purple bit down here, required peering capacity, what I'm basically doing is saying, okay, 30% of 60 gig, 30% of 60 gig, and 30% of 60 gig all adds up. I need at least 54 gigs of capacity, so I need at least a 100 gig port on the exchange. Or I guess you could do 6 by 10 gig. That would add up a little differently. But I know that I need at least 54 gigs worth of capacity on the exchange in order to see this cost savings that I'm expecting.
Yeah, I'll just make one other note about this. So, every company, the finance department has their own, if it's large enough to have a finance department, it has a template for you to, and they call it different things. So I've seen it called a business case, a business plan. I've seen it called a business development request, a BDR. There's all kinds of different terminology for this, but these models all have one thing in common. They're typically laid out in a 5-year plan with one column per month for the whole 5 years, and then different rows for income, cost reductions, whatever, and upfront costs will go into a column, and then they have a bunch of stuff hidden behind them, like things like a discount rate. And what I have always found easiest is, instead of trying to take this, which we can make sense of what you're seeing on the screen here, and then try to like translate it mentally into the different cells that are in the template that my CFO wants to fill out. I instead just take this tab and put it right into the business case as a extra tab, and then start to reference these cells from the main template body. And so when you have like a non-recurring charge, you go and you put that, in month 0, and you put that as the cash outlay. And then, for the cost savings, you start to put those in, and you draw those out over time. That way, like, the CFO has all of the detail information, right? This is, as engineers, we look at this and we can make sense of this and use this as a good planning tool. But the CFO, when he wants to see ROI, he wants to see it represented usually as a percent. And that percent takes into account not just the accounting based numbers of the numbers, but the timing of the numbers as well. And it also is going to spit out some other metrics that he wants to see. You might want to see internal rate of return is another very common one in addition to ROI, and almost always wants to see an NPV.
Yeah, net
And
present value. Yeah.
net present value. And net present value is a representation of whether or not this project is going to provide a return to the company that is more than what the shareholders are expecting or less than. So if it's a positive NPV, it means that, like, not only do we get to provide the return to the shareholders, but we get to keep some for the company itself. And if it's a negative NPV, it means that it's not going to return enough to provide the minimum return that the shareholders are expecting. So they want to see those values. So this is not intended to be like a replace your CFO's template, but this could be really handy for you once you do all your homework and you put it into this model. Then you drop it into your CFO's template, and then you tie the CFO's template values into this, and now everything ties together. And you always have your numbers. If the CFO says, "Oh, well, what if it's not as much traffic as we expected?" Well, you can go back into this template and you can change the bandwidth amount and say, okay, well, what if it is half as much? And you can see how the entire financial model updates right there in front of his eyes with different NPV, IRR, and ROI. So hope
Like a
this
big
was super useful for you guys. We'll open it up and ask if there's any other questions on how to use the tool,
As those
or
questions are coming in,
anything.
I just wanted to answer. We had one comment from Mike, I believe, asking about the equipment costs for transit. And you're definitely right. The way I built this, the way Dave and I looked at this was assuming that you are already, in a market, have transit, and you're thinking about adding peering. But you're 100% right. If this was a brand new market for you, and you're looking at what the balance is between transit and IX, you might want to add in more of those costs, right? And in that case, it gets kind of complicated though, because it's possible that you're going to buy one router to do transit and peering connections, and it's going to go in one cabinet, and it's going to have one set of transport, and so you could actually be sharing that cost. And then how do we divide the cost between the peering relationship and the transit relationship? So we did take a simple approach here and said, okay, let's say you've already got a router sitting somewhere doing transit and you're thinking about adding peering. This is great for that. But there are definitely a lot of other situations where you need to add some additional information in addition to the financial stuff that Dave was just going over.
Guy says, I hope people don't put transit and peering on different routers anymore. Probably not. As long as they're all tied into the same route reflector, and then you have separate edge devices too. It all depends on your scale. But I certainly don't. I put them all in the same router generally.
Or if I'm doing like a redundant edge, or I've got two edge routers, maybe I'll put half the transit connections and half the peering ports on one. Connect the one exchange and one transit provider on one router, and one exchange and one transit provider on another one. Split them that way. But yeah, having all peering on one and all transit on another is an artifact. But I don't know if there's anybody still doing that or not. There was for a while, and it was because it was an organizational thing for some companies, right? Just the way they were set up, it was different teams, and they didn't want to have one
It,
team poking the other team's
it
router,
only
if I remember
takes it
right.
only takes one outage at peak time
And
to
people start doing weird stuff.
highlight the risks and the downsides of that particular architecture. Like anybody you don't peer with, if your transit router goes down, so guess what? You're backhauling all that traffic into a different market. Yeah, and the backbone probably fills up too, like Guy's pointing out. Of course, it does depend on the traffic pattern that you have. If you're mostly an ISP or mostly content, that can play a big role in what exactly happens when the mistakes of your architecture and design reveal themselves. But most of those things can be avoided anyway, just thinking through the different scenarios. See, we are almost out of time. We're looking at
Pretty good timing.
and we got about 5 minutes left. Um, I I just want to thank everybody for joining. Chris and I love talking to you, and the fact that you all are here and participating with us live and asking questions makes. I mean, this made this a lot of fun for Chris and I. So thanks for coming.
Absolutely. Yeah, here.
And in closing, if any of you need additional help, additional firepower, additional advice, additional support with your CFO, additional support on modeling, any of those kinds of things, Net Mavens is here to give you a hand. So reach out, and we'd love to help. All right. Well, thanks again, and thank you, Chris.
Yeah. Thanks, Dave. Thanks, everybody.
Bye now.